Hello guys, welcome to Unacademy NEET English YouTube channel. I'm Kailash Sharma and today I'm going to teach you projectile motion. So this topic we will cover in detail. We will solve numericals and this session is going to be very helpful for all the students preparing for NEET 2024. They can revise this topic through this session. This is a marathon session where the complete topic will be covered in detail. I hope I want all of you to understand one thing, that this topic is linked with the previous topic that I have already covered on this channel. That was the motion in one dimension or the rectilinear motion. So like many concepts of the rectilinear motion are directly used in this. So if you have missed that session, if you have missed the PDF of that session, that you can download from the Telegram and you can watch you have to watch the previous session as well. So projectile motion, complete projectile motion will be covered in the next 3 to 4 hours. This is a small topic, so only 3 to 4 hour duration will be the lecture duration for today's session. So how are you doing today? So projectile motion by Kailash Sharma sir. This is the topic which we have to complete in next 3 to 4 hours. So how is the Joes? How is the Joes? Before I start the class, I want to see the excitement level, the energy level of you. So you people are ready for the class or not? That I want to see in the chat box. So how is the Joes? And please do not forget to like the session. You all have to like the session. Yes, I can see that now. So please like the session. Before we start, we go ahead. You have to like the session, share this session, share the session among your community, among your friends, and do not forget to subscribe this YouTube channel where all the faculties are doing great work. They all are dedicatedly teaching in this series where they are covering one topic each day in a subject is being covered on this channel, and every faculty is doing great here, and like they are giving their best to make your preparation to make the best preparation for the NEET 2024. Okay, sir, why are you okay, so we start the session projectile motion. Projectile motion I am about to start. I'm just waiting that all the students who are regular to the session must join the session, and then we can start the session. Okay. Okay. So have you all liked the session? Before I start the session, I want all of you to like the session. Then we start the session. Okay. Okay, so I'm going to start the projectile motion. Projectile motion, which is a very important topic. You can see the PYQs. Almost every year a question is asked from this topic. So from the exam point of view, this topic is very, very important topic. So you all have to complete this topic in detail. I'll write each and everything on the board. You can make the short notes through this session, and there are like almost 20 questions which we will discuss during this session. Okay, so there are 20 questions. So 20 questions will complete will cover each and every concept of this topic. Each and every concept will be covered in those 20 questions. So whatever I am going to teach, I have planned questions on that concept. We will cover all the formulas, their derivations, the way the tricks which we using them. You can memorize these formulas. You can you don't have to memorize these, I'll tell you the tricks which you can use and you can derive the formula in less than 30 seconds. So there are certain tricks as well that we will discuss. So I'm about to start the session. Before this session, I start there is a NEET Endgame 2.0 Ultimate Crash Course for NEET 2024. Which is starting on the 22nd January. These all are the faculties in this batch. So this batch is now available at only 4,499 rupees. So almost 4,500 rupees you have to pay to enroll in this batch, and this batch is ultimate crash course for the NEET 2024. So anyone planning to join this batch can use this referral code, which is the Kailash 10. Using this referral code or a referral code given in the description, like a link of this batch is given in the description. You can go and see the syllabus of this. Like you can, if you want to know more about this course, you just click on that link given in the description and you can go through the information about this course. Okay, so let's start the session for today, and that is the projectile motion. So projectile motion, what are the real life example of the projectile motion? Have you ever any situation you want to share with me, like that where you see the projectile motion, that body is doing the projectile motion? So let me tell you some real life examples. When a batsman hits the ball for a 6, the ball is in air. The motion of that ball is projectile motion. So ball is moving under the gravity and it is going on a curved path like this, and that motion is called the projectile motion. Or you throw anything in air, not vertically upward, at an angle, like this is this remote, the slide changer, I throw like this. So the path followed by this slide changer, or the motion of this slide changer, will be the projectile motion. So whenever you throw anything in air which is not vertically upward, the motion of that body will be projectile motion. But there are certain conditions as well. Okay, so everybody will not be doing the projectile motion. Like in gravitation, we study like if a body escape, then the path will be different, the motion will be different. So there are certain conditions as well. We will talk about them. But are you able to understand, okay, what is the projectile motion? So you are throwing anything in the air and not vertically upward. So you can throw vertically upward also, no? That is also in air. So not vertically upward, but at some angle, and the motion of the body will be the projectile motion. So body will be doing the motion under the gravity. Okay, so all these things we will write here, like definition and everything. I'll write on the board, and you can note down that as well. So what is projectile motion? 1 minute. Somebody has changed the settings of pen. Not this one. Yes, projectile motion. Okay, so projectile motion is a motion in a plane. Projectile motion is a motion in plane. Motion in plane with uniform acceleration. With uniform acceleration. So projectile motion is a motion in a plane with uniform acceleration. So projectile motion is a motion in plane with uniform acceleration. So motion under gravity of Earth. The acceleration during the projectile motion is g, which is vertically downward. So when a body is in air, the only force acting on it is mg, which is vertically downward. There is air drag as well. We do not consider air drag. So the only force acting on the body is mg, which is vertically downward. So the acceleration of the body is g, so which is constant. So projectile motion is a motion in plane with a uniform acceleration, and that is the acceleration due to gravity. When a body is projected obliquely, near the Earth's surface, in the air, it moves in horizontal, it moves simultaneously, it moves simultaneously in horizontal, it moves simultaneously in horizontal and vertical direction. It moves simultaneously in horizontal and vertical direction. Motion of such body is called the projectile motion. Motion of such body. Motion of such body is called the projectile motion. Okay. So motion of such body is called the projectile motion. So when a body is projected obliquely near the earth's surface, obliquely matlab you are not throwing it vertically upward, at some angle. So when a body is projected obliquely or at some angle near the earth's surface in air, it moves simultaneously in the horizontal and the vertical direction. The motion of such body is called the projectile motion. So the motion of in projectile motion, the body is moving in horizontal direction as well as in vertical direction. So there is a two-dimensional motion. The body will be moving vertically and horizontally, both simultaneously it will be moving, and it is projected obliquely. It is projected at some angle other than 90 degree in the air, and motion of such particle is called the projectile motion. There is one more thing. I have written here like near the earth's surface. What is the meaning of that near the earth's surface? Near the earth's surface means like we will consider the value of g constant throughout the motion. So when with height value of g changes, so we are not considering that particle is not going to very high, like the value of the change in value of g due to the height is negligible. So we are talking for only such motions where the height of the body is not that much. So when a body is projected obliquely near the earth's surface in air, it moves simultaneously in horizontal and vertical direction. Motion of such body is called the projectile motion. Air drag is neglected in this motion. Air drag is neglected. So the only force acting during the motion, only force acting during the motion. So the only force acting during the motion is mg. Hence, acceleration during the motion is g vertically downward, is g which is vertically downward. So in projectile motion the acceleration is vertically downward and which is equal to g. So in projectile motion only force acting on the body is mg, and because of that the acceleration will be g which will be vertically downward. Is this clear? Is this clear? Any problem here till now? The projectile, what is the projectile motion? So projectile motion is a motion in plane. It is a motion in plane. The body is moving in a plane with uniform acceleration. And what is that acceleration? That acceleration is g, which is vertically downward. We are not considering air drag. Only the particle is moving under the gravity of the earth only. Okay, you have given some velocity, and with that velocity the particle is moving under action of gravitational force, and the acceleration of the body is g during the motion. The height of body is not that much that we don't have to consider the change in the gravitational acceleration. We will consider the acceleration constant throughout the motion, and body is moving in the horizontal as well as in vertical direction. So these are the definition of the projectile motion. So these all are the definition. So let's discuss a case where I'll try to explain that why there are two type of motion involved. One is the vertical and the other is the horizontal motion. So what is the meaning of this line? We are going to understand with the help of this example. So I'm going to explain a situation where there are two particles. So there are two particles, okay. One particle is projected vertically upward. One particle is projected vertically upward. Can I fill it? No. With a velocity of, this particle is projected vertically upward with a velocity of 20 meter per second. This is projected with 20 meter per second. So there is a particle which is projected vertically upward with 20 meter per second. So this we have already studied in rectilinear motion, which was the previous topic, where a body is projected vertically upward. So what will be the motion of this body? This will go up and come down, okay. It will perform rectilinear motion. The force acting on it is mg only, so there will be downward acceleration g of this body, okay. So there will be acceleration due to gravity, which will be g. What will be the motion of this body? What will be the motion of this body? So at t equal to 0, this body is projected. At t equal to 0, this body is projected. So this body is projected at t equal to 0. So what will happen here? In 1 second, it will travel 15 meter and will be moving with 10 meter per second. So at t equal to 1, this body will be moving with 10 meter per second and it has traveled distance of 15 meter. At t equal to 2, the velocity of this body will be 0. Here the velocity is 20 meter per second. In 1 second it will become 10 meter per second. In next 1 second it will become 0 meter per second. This all I have covered in the previous chapter. And you can easily find it like v equal to u minus ka gt. So you put t equal to 1, v becomes 20 minus ka 10 into 1, which comes out to be 10 meter per second. V equal to u minus ka gt, when you put t equal to 2, velocity will be 0, okay. So this way it will go up and then it will come down. So this is the upward motion, like it went up and now it will be coming downward. So at t equal to 3, it will be moving with 10 meter per second in vertically downward direction. And at t equal to 4, it will be moving with again 20 meter per second, okay. It will go up and come down like this. So when a particle is projected with 20 meter per second, it goes up in 1 second 15 meter, in another second 5 meter. So total maximum height attained by this is 20 meter. So 20 meter it will go up and then come down like this in 4 seconds. So this is happening with this particle. There is one more particle. Let's say there is one more particle and that particle is moving in horizontal direction. So there is one more particle and that particle is also given motion, but that motion is given in the horizontal direction. So the particle, to this particle the motion is given in horizontal direction. And what is the velocity given to this? So this is 15 meter per second. So let's say the motion given to this particle is 15 meter per second and they are these both events are happening at the same place. So this particle is going in this direction. So will it have any acceleration? No, this is moving on a smooth surface. So in 1 second it will travel 15 meter. At t equal to 1, the particle will reach, will cover 15 meter. At t equal to 2, particle will cover again 15 meter. At t equal to 3, particle will cover again 15 meter. And t equal to 4, particle will cover again 15 meter. So distances traveled in each second will be 15 meter. in this case. Okay, so in this case the distance traveled will be 15 meter in each case. So this is also 15 meter, this is also 15 meter, okay, this is also 15 meter, this is also 15 meter. So this is 15 meter, 15 meter, 15 meter, 15 meter. Okay, these are all the distances covered. 15, 15, 15 meters. So this particle moving with 15 meter per second will cover equal distance in equal time interval. So in every second it will cover 15 meter, 15 meter, 15 meter, 15 meter. So in 4 seconds it will reach here. In 1 second it will reach here. In 2 seconds it will cover 30 meter. In 3 seconds it will cover 45 meter. In 4 seconds it will cover 60 meter. So there are two different motion. One is in the horizontal direction, one is in the vertical direction. So there are two particles. There are two particles. One is moving in the horizontal direction, one is moving in the vertical direction. So the motion of this particle is motion under gravity, and motion of this particle is uniform motion. It does not have any acceleration. What if we give these two motion to single particle? What if we provide these two motion to the one particle only? What if we give both the motion to only one particle? So there is third particle which is given these both the motions. Okay, we are providing both the motion to the one particle only. So let's say there is one particle, this one, white color. Okay, so this particle is given both the motion. So this particle is given horizontal velocity 15 meter per second and the vertical velocity 20 meter per second. So what if I give horizontal velocity to the particle which is 15 meter per second and vertical velocity which is 20 meter per second to one particle? So I have done, like, I have given a single both the velocity to the single particle. So what will be the resultant of these two? So the resultant of these two will be 25 meter per second at an angle of 53 degree. So what if I project a particle with 25 meter per second at an angle of 53 degree? What if I project a particle with 25 meter per second at a 53 degree? So what will happen here? So particle will have vertical component of velocity and horizontal component of velocity. It will have vertically downward acceleration. So these two motion will overlap now. Like, it is doing both the motion. Means the vertical motion will be similar to this and the horizontal motion will be similar to this. So when you project a particle with 25 meter per second at 53 degree angle, the vertical component of the velocity will be 20 meter per second and the horizontal component of the velocity will be 15 meter per second, and now the motion will be like, there is no acceleration in this direction. So the motion in this direction will be motion with uniform velocity. There is acceleration in this direction which is equal to g, which is vertically downward. So motion in this direction will be motion under gravity, acceleration due to gravity. So in 1 second, due to this direction motion which is 15 meter per second, this particle is moving in this direction. So in this direction, in 1 second it will travel 15 meter. So particle will be here at somewhere. But in this direction it is traveling 15 meter as well. So wait 1 minute na, like let me mark this distance. So this distance is 15 meter and this distance is 5 meter. Both the distances are given like this. So this is 5 meter, this distance is 15 meter. Okay, this distance is 15 meter, this distance is 5 meter. Let me draw some lines as well. Like this is the line of, this is the line with where y is equal to 15 meter. Okay, this is the line where y equal to 20 meter. This is the line where x is equal to 15 meter. Where x is equal to These lines I have drawn. Okay. Now what is actually happening here? So particle is starting motion from here. Okay, particle is here. It is given a 25 meter per second velocity. So in 1 second it will travel 15 meter in this direction and 15 meter in this direction, means this particle will pass through this point. Okay, this particle will pass through this point. In next 1 second, in this direction it will again cover 15 meter, but in this direction only 5 meter. Particle will be here. When it is coming down, after at t equal to 3 seconds, particle is at a y equal to 15 meter and x will be 45 meter, and at t equal to 4, particle will come at this point. So the motion will be like this. This is the motion of the particle. The path of the particle will be like this. So like projectile motion is the combination of two independent motion. One is in the vertically upward direction and one is in the horizontal direction. So projectile motion is combination of two rectilinear motion. So I teach it like that only. So projectile motion is the combination of two mutually perpendicular see, this way if you solve the problem now, you will never find projectile motion difficult. So projectile motion is combination of two mutually perpendicular rectilinear motions. Rectilinear motions. So projectile motion is combination of two mutually perpendicular rectilinear motion. In vertical direction, motion with uniform acceleration. In vertical direction, its motion with uniform acceleration. In vertical direction, it is motion with uniform acceleration. In horizontal direction, it is moving with uniform velocity. Okay, so in horizontal direction, the motion is motion with uniform velocity. So basically projectile motion is nothing but it is a combination of two mutually perpendicular rectilinear motion. So one rectilinear motion in vertical direction, other rectilinear motion in the horizontal direction. That's all. So when you project a particle with 25 meter per second at an angle of 53 degree, what will you do? You will break the you will have the x component of the velocity, you will have the y component of the velocity. In vertical direction there is acceleration as well. In this direction particle will go up and then come down, but in this direction it will be continuously moving with uniform velocity. So when you project this particle, like it go up in 2 seconds and then come down in 2 seconds. So at t equal to 1 second, this is the t equal to 1 second. So at this moment, the horizontal component is 15 meter per second, but the vertical component becomes 10 meter per second. The horizontal component of the velocity is 15 meter per second. Throughout the motion, horizontal component of the velocity will remain constant, but vertical component will become, in 1 second, it will become 10 meter per second. Here the vertical component of the velocity is 0. But there will be horizontal component of the velocity which is 15 meter per second. Here the vertical component will be 10 meter per second downward. Horizontal component will be 15 meter per second. Here also horizontal component is 15 meter per second. Vertical component will be 20 meter per second. So the motion is like this. The distance covered in 1 second in horizontal direction will be 15 meter, because in this direction it is moving with the constant velocity, but in this direction it is also 15 meter. But In the next 1 second, the distance traveled in this direction is 15 meter, but the distance traveled in this direction is only 5 meter. So this is 5 meter, this is 15 meter. So this is the maximum height. At maximum height, y component of the velocity becomes 0. This distance is called the range. Horizontal distance traveled during the motion is called the range. So horizontal distance, vertical distance, are you able to understand it? So projectile motion is nothing but it is a rectilinear motion in two mutually perpendicular direction. This is the way I teach it. Like my way of teaching the projectile motion is quite different. You don't have to remember all the formulas. You can simply split the motion into mutually perpendicular direction and just deal with the two rectilinear motion. You will be able to find any question, solution of any question. You have to just do it. So what we are doing here, we are just splitting the like projectile motion. It can be divided in two rectilinear motions. Okay. So rectilinear, this we have already studied. This we have studied in the previous chapter. That was the motion under motion in one dimension or rectilinear motion, where I taught you, like if a particle is projected with 20 meter per second, it will go to 20 meter height. In 1 second, it will be traveling. After 1 second, it will be traveling with 10 meter per second. It will have covered 15 meter distance. In next 1 second, it will cover 5 meter, then 5 meter, then 15 meter, 20 meter. It will go up and then come down. But in the horizontal direction, there is no acceleration. So there is no acceleration. That means that the horizontal motion will be uniform. So particle will be continuously shifting towards horizontal direction. So what is happening here? In vertical direction, particle is going upward and then downward. But in horizontal direction, it is moving with a constant velocity. So when you project a particle obliquely, it is simultaneously moving in the horizontal as well as in the vertical direction. So path of the particle becomes like, and that is called the projectile motion. Got it? Is this clear to everyone? I'll break each and every projectile motion question in this kind of question, and you will see I'll be able to solve the questions like just like that. Okay. So now horizontal and vertical direction, we will call them x and y direction. Okay. So this thing, the motion in x direction is totally independent from the motion in the y direction. So when there are two mutually perpendicular directions and you have done all the component of all the vectors, velocity, acceleration and everything, then both the motion x and y direction motion are independent from the each other. Okay. So x and y direction are independent from the each other. So there are formulas for the projectile motion. So we are going to derive them. But before that, I need to draw a diagram here. And now finally we are going to see how we will be dealing with the questions of the projectile motion. So if there is a particle which is projected from here, if there is a particle which is projected from here, and there is a x direction and the y direction. Okay. So there is a particle which is projected like this with a speed u at an angle theta. This is the x direction and this is the y direction. Okay. X and y direction are there. So particle will move like this. It will move like this. What we will do is we will break this projectile motion in two mutually perpendicular rectilinear motion. One in the x direction, other in the y direction. We'll call this velocity as a ux, which is u cos theta. Call this velocity as a uy, which is u sin theta. Okay, so we will break this u into mutually perpendicular directions. There will be acceleration as well in this direction, in y direction only. There is acceleration in y direction. So this is the acceleration in the y direction. So this motion is the x along the x-axis. This motion is along the y-axis. Here we will write both the motions. So along x-axis, what is happening along the x-axis? So along x-axis, everything along x-axis will be written here. So along x-axis. So what are the things happening along the x-axis? So velocity along the x-axis ux is given as u cos theta. Is there any acceleration along the x-axis? No. Acceleration is not along the x-axis, so this remain constant. Velocity along x-axis remain constant. So velocity at any time along the x-axis in this direction, velocity will be equal to ux only, which is equal to u cos theta. This is called the x component of the velocity. This is called the x component of the velocity. So velocity along x direction will remain constant. Displacement along the x direction at any time, so x coordinate will be equal to u cos theta into t. The x component of the velocity into time will be the displacement along the x axis. Along the y axis, what is happening along the y axis? I'm just breaking both the motion. Along y axis, in this direction, what is happening in this direction? So u in the y direction is equal to u sin theta. Acceleration in the y direction is equal to minus ka g. In this direction, acceleration is this. So velocity in y direction will be equal to u sin theta minus ka gt. This will be the velocity. If you want to write the velocity at any time in the y direction, the component of the velocity in the y direction will be written by this formula. Okay. Height in y direction at any time is equal to u sin theta into t minus ka half gt square. This is the height of the particle in y direction. And there is one more formula in y direction, third formula, and that is called the vy ka square is equal to u square sin square theta minus ka 2 into g into h. These are all the formulas which can be used to explain the complete motion of the complete projectile motion. Okay, so complete projectile motion can be understood with the help of only these all formulas. In the x direction, it is moving with the constant velocity. In the y direction, it is moving in the y direction there is a motion with uniform acceleration, and acceleration in the y direction is minus ka g. So velocity can be written like this, height can be written like by this formula. So all the three equation of motion which are used for the motion with uniform acceleration can be used to write the velocity displacement in the y direction. So y direction motion can be explained using these equations. So is this clear to everyone? Like everything on this page is clear to everyone? Now we are going to derive the formulas, na? Like we have seen how do we break this motion in x and y direction. I have already told you, like along the x-axis, what is happening here? Along the y-axis, what is happening here? Once we will be solving the problems, na, like everything will be crystal clear to everyone. So motion in x direction is without any acceleration. It is continuously moving with a constant speed. At every moment, the horizontal component of the velocity will be same. But in y direction, there is acceleration. It will while going upward, it will slow down, and at the highest point, it will have the zero velocity in this direction, and then it will again start coming down. It will go up and will come down. This kind of motion will be there in vertical direction. Done. So let's define the formulas in the projectile motion. So this is y-axis and this is x-axis. So when you project a particle, with a speed u at an angle theta, it goes like this. This height is called h max. This height is called h max. This distance is called horizontal range. Capital R. Time at this point is called the time of flight. When the particle falls on the ground, now it is called the time of flight. So x-axis, and that is the y-axis. Okay, like this. So let's find the time of flight. So first concept is the time of flight. Capital T. So first concept is the time of flight, which is this concept. So the time for which the particle was in air is called the time of flight. Particle was in air for some time, and that is called the time of flight. Okay. So time in which particle return back to the horizontal ground is the time of flight. The particle started from here and it is reaching the ground again, and that time is the time of flight. So time in which displacement of particle becomes 0 in vertical direction. In vertical direction, not in horizontal direction, in vertical direction. That time is called the time of flight. When particle started from the ground and it is again back to the ground, that time is called the time of flight. So displacement in vertical direction is given by this formula, u sin theta into t minus ka half gt square. Okay, so this is the displacement in the y direction formula. Now we are putting 0 in place of y, and this comes out to be u sin theta into capital T minus ka half g into capital T ka square. So t is equal to 0 and t is equal to 2u sin theta divided by g. So t equal to 2u sin theta divided by g is the time of flight. So this is called the time of flight. This time is the time of flight. Okay, 2u sin theta divided by g. So t can be written like t equal to 2uy divided by ay. This is the time of flight of this particle. Is this clear? Time of flight. Time of flight formula is clear. How do I decide the time of flight formula? Like, how could I find the time of flight? So I know one thing, that in vertical direction it is going upward and then coming to the ground again. So in vertical direction the displacement becomes 0. So the time in which the displacement in vertical direction becomes 0 is called the time of flight. So it is going upward and then coming downward on the ground. Displacement in y direction becomes 0, equal to capital T, and that capital T is called the time of flight, and that is given by 2u sin theta divided by g. Yeah, 2 into velocity in the vertical direction divided by acceleration in the vertical direction. That's all. Okay, so this is the formula of the time of flight. How do we find the maximum height? What is the maximum height? This height is the maximum height. So maximum height is in the vertical direction. Here velocity in the y direction becomes 0. Velocity in the y direction becomes 0. So to find the maximum height, what I can say is maximum height when you could say displacement in the y direction, displacement in y direction when displacement in y direction when Vy is equal to 0 is h max. So when particle stops going upward, at that time the height of the particle is called the h max. So displacement in y direction when velocity in y direction becomes 0 is called the h max. So which equation I can use? Vy का square is equal to uy का square minus का 2g into y. So in this formula I'll put Vy equal to 0. 0 का square is equal to u square sin square theta minus का 2 into g into h max. So the formula of the h max is u square sin square theta divided by 2g. So this is the h max. U square sin square theta divided by 2g is the h max. So h max is given by this formula as well. H max we can write like H max is uy का square divided by 2ay. This is the H max. So H max is given by this formula. H max is done. Time of flight is done. How did I derive these formulas? Are you able to understand that or not? Like when I was finding the time of flight, what did I do? I said particle started from the ground. When it reaches back to the ground, that time is called the time of flight. So displacement in vertical direction becomes 0. So it is at the same horizontal level initially and finally. So I just found the time when displacement in y direction becomes 0. So I have an equation of displacement in y direction. That is the second equation of motion in the vertical direction. So along y-axis, I have equation which relate the displacement with time. That is y equal to u sin theta into t minus half gt square. So in that equation, I put y equal to 0, and the time I calculated, that was the 2u sin theta divided by g, and that is the time of flight. When I was calculating maximum height, so when I was calculating maximum height, so maximum height, when you define the height is maximum, when something stops going upward, at that level, that height is called the maximum height. So something is going upward. It has velocity in vertical direction, so it is going upward. When it stops moving further and it start coming downward, that height where it is stopped is the maximum height. So I said at the time of maximum height, the velocity in y direction will become 0. So I said velocity in y direction 0. At that time, the height is at that time the displacement in vertical direction is the maximum height. So we have three equations of motion in the vertical direction, because in vertical direction it is the motion with uniform acceleration. So I use the third equation of motion, which is the vy ka square is equal to uy ka square plus ka 2ay into y. Here velocity in y direction becomes 0. Uy is equal to u sin square theta. At place of y I put h max. So h max is equal to uy ka square divided by 2ay. So h max is equal to uy ka square divided by 2ay. Okay, maximum height is done. Now let us talk about the range. Horizontal range. Horizontal range. So horizontal range, which we define like R. R is the horizontal range, na? So during flight time, the horizontal displacement is called during flight time, the horizontal displacement is called horizontal range. So when it is moving, the horizontal distance traveled is the horizontal range. So horizontal displacement is the horizontal range. So horizontal displacement is given by x, which is equal to ux into t. So when t becomes time of flight, at that time x becomes r. So in total time of flight, the horizontal distance traveled is the range. So ux is u cos theta, 2u sin theta divided by g. So r comes out to be u square sin 2 theta divided by g. So this is the formula of the R. So let me put it here. So R is given by this formula, U square sine 2 theta divided by G. So this is the formula of the horizontal range, U square sine 2 theta divided by G. This is the horizontal range. Okay, so now we have three formulas: H max, horizontal range, and time of flight. These are three very important formulas. Now there are few important points about the horizontal range. Okay, there are few important points about the horizontal range. Important points about horizontal range. Important points about horizontal range. So, what are the important points? When a particle is projected at an angle alpha, when a particle is projected at an angle alpha, when it is projected at an angle of 90 minus alpha, so this angle is alpha. This angle is 90 minus alpha. Particle will go like this, and in this case also go like this. So range is same for two angles of projection. So the first point is horizontal range. Horizontal range is same for two angles of projection. So R for theta is equal to alpha is equal to R for theta is equal to 90 minus alpha. And these two angles are called the complementary angle, but H is not same. H for theta is equal to alpha is not equal to H for theta is equal to 90 minus ka alpha. The height, maximum height will be different for both the angles, but the range will be same for two angles which are complementary angles. Okay. So the angle which is smaller, H max will be small, and for the angle with the bigger angle, the H max will be bigger for the angle which is greater than 45 degree. So for so let's say if a particle is projected at 30 degree with speed u, it will have same range when it is projected at 60 degree. So 30 degree and 60 degree for the two angles, 30 degree and 60 degree, the particle will have same range. So horizontal range is same for the two angles of the projection. For alpha and 90 minus alpha, horizontal range will be same. But maximum height will be different. But maximum height will be different for both. So H1 max will be equal to U square sine square alpha divided by G. But the H2 max will be equal to U square sine square 90 minus alpha divided by 2G, which comes out to be U square cos square alpha divided by 2G. Okay. So the maximum range, maximum height will be different for both the angles. For the alpha and 90 minus alpha, maximum height will be different. Okay, next one is concept of maximum range. So concept of maximum range. Concept of maximum range. So formula of R is equal to U square sine 2 theta divided by G. So when sine 2 theta is maximum, sine 2 theta is maximum, the range will be maximum. So when sine 2 theta is maximum, range will be maximum. So what is the sine 2 theta max is equal to 1. So range maximum will be equal to U square divided by G. So maximum range will be equal to U square divided by G. This is the formula of the maximum range. R is maximum when sine 2 theta is equal to 1, means 2 theta is equal to 90 degree. So theta is equal to 45 degree. So at 45 degree the range will be maximum. So angle of projection, if you make 45 degree, range you will get maximum. To get maximum range for a particular speed. So speed, when you keeping the speed fixed at different angle, the range will be different, and at angle of 45 degree the range will be maximum. What will be the maximum range? That is given by U square divided by G. The maximum range is U square divided by G. So these are all the formulas of the projectile motion. All the formulas of projectile motion I have just covered. We have to just break the motion in the two mutual perpendicular direction, x direction, y direction. Horizontal direction is the x direction, vertical direction is the y direction. In horizontal direction there is no acceleration, so the motion will be motion with uniform velocity. It will be continuously moving with the same velocity in the horizontal direction. Whatever distance is covered in the horizontal direction, anytime t can be written like ux into t. And along the y direction, it is a motion with uniform acceleration, which is g vertically downward. And with the help of like we have studied in the previous chapter that when acceleration is constant, velocity is given by v equal to u minus ka gt. When acceleration is equal to minus ka g, and height is at any time a displacement in vertical direction is given by this formula, u sin theta t into t minus ka half gt square. Vy square is equal to u square sin square theta minus ka 2gh. These are all the formulas which we will use later to derive all these other formulas. Time of flight, when particle start from the horizontal and come back to the horizontal level, that time is called the time of flight. So displacement in y direction we just did equal to 0. So from here we got the time of flight t equal to 2u sin theta divided by g. And maximum height, for the maximum height, when the particle stops moving upward, where velocity in the y direction becomes 0, at that time the height is equal to maximum height. So we got the maximum height is equal to u square sin square theta divided by 2g. And horizontal range, distance traveled in the horizontal direction during the flight time is called the horizontal range. So horizontal range we got u square sin 2 theta divided by g. And there are two angles for the same range. One is alpha, then another angle is the 90 minus alpha. And for these two angles we get the same range, but we do not get the same height. Same height will be different for both the angle. The angle which is bigger, height h max will be different. H max will be more than the other h max for the other angle. Concept of the maximum range. So in case of the maximum range we get at if we project a particle at theta equal to 45 degree, we get the maximum range is equal to u square divided by g. These are all the formulas of projectile motion. So now we will solve numericals on this part. Numericals. So if a projectile is fired at an angle theta with the velocity u, then the maximum height attained is given by. Can you answer this question? So this is a kind of rapid fire round. Okay, so there are like 10 questions, almost 10 questions, and we will solve those 10 questions. Those 10 questions are based on the concepts which I have just taught you, and after that there are 2-3 more concepts. This topic is actually not that big. So so let's solve some numerical. Okay, so what is happening here? What is happening here? So third option is the correct option. So what should be the answer of this question? So jaldi, you have to answer this question. So you have 10 more seconds remaining. So what should be the answer? What should be the answer of this question? So sometimes this is a very easy question actually, na? But sometimes when we are not focused and like we are just not reading the things properly, then we are like, there is a high probability that we will commit a mistake. What is happening here is, if a projectile is fired at an angle theta with vertical, they have given that this theta is given with vertical, this is not with the horizontal. Okay, so the theta is not given with the horizontal. What is happening? The particle is projected like this. So you did not read it properly. Okay, so u is this and this angle is theta. So we need this angle alpha, which is 90 minus ka theta. So formula of the H max is u square sine square alpha divided by 2g. So you put alpha is equal to 90 minus ka theta, sine 90 minus ka theta divided by 2g, and you get u square cos square theta divided by 2g. So the answer of this question is fourth one, which none of you gave this answer. None of you gave this answer. Almost every student was saying that second or third is the correct. So D option will be the correct option. So can you see, like this topic you have already studied. Most of the, like I can see the chat, the type of chat is like you are overconfident in this chapter. In the first question, which is the very easy question, most of you have just solved it wrong. So learn from something from this question, huh? Like don't waste your time on unnecessary chat. Focus here, you will learn something. There are so many questions I have planned for this session, and if you are able to understand all those questions, you will be very confident in this chapter. So don't get distracted by these comments or the chat which is happening here. Okay, this was the first question. Let's solve question number 2. The range of the particle when launched at an angle of 15 degree with the horizontal is 1.5 kilometer. What is the range of the projectile when launched at an angle of 45 degree to the horizontal? So what will be the range in this other case? If it is projected at an angle of 45 degree, initially it was projected at 15 degree. When projected at 15 degree, the range is 1.5 kilometer. When projected at 45 degree, what will be the range? What will be the horizontal range? This is a simple question. Okay, anyone? So I can see a few answers in the chat. That is question like first option and the second option. So you are saying the first option is the correct, you are saying the second option is the correct. Like there is a variety in the answers. So the answer of this question is how do we solve this question? The formula of the range is r is equal to u square sine 2 theta divided by g. So when you put theta is equal to 15 degree, it becomes u square sine 2 into 15 divided by g. So this becomes sine 30. So u square divided by 2g. and this is given as 1.5 kilometer. The value of u square divided by g comes out to be 3 kilometer. Okay, now when theta is equal to 45 degree, when theta is equal to 45 degree, so range becomes u square sine 2 into 45 divided by g. So range becomes u square divided by g, which is equal to 3 kilometer. Okay, so 3 kilometer will be the answer, and the students who gave the second option as the correct option are the correct. Like this option is the correct option. So B option is the correct option. Got it? So this level of question can be asked on these formulas. These are very easy questions. Are you able to solve them or not? Like, let's move to the question number 3. A cricketer can throw a ball to a maximum horizontal distance of 100 meter. The speed with which he throws the ball is, what is the speed? What is the speed with which ball is thrown by the cricketer? So cricketer can throw a ball to a maximum horizontal distance of 100 meters. So R is maximum when theta is equal to 45 degree. Okay, R is maximum when theta is equal to 45 degree, and the formula of R max is u square divided by g. They are saying maximum distance is 100 meter, then u square divided by g. So u comes out to be 10 root 10. Value of root 10 is approximately equal to 3 point something. So it will come out to be 32 meter per second. Out of these 4 options, this option is very close. 32 meter per second will be the answer. Is this clear? Is this correct? Okay. Question number 4. Like, there are 10 questions. We'll solve them a little fast, and then I'll teach you the next concept, that is the horizontal projection from the height. Okay. Question number 4. Two bodies are thrown up at an angle of 45 degree and the 60 degree respectively with the horizontal. If both bodies attain same vertical height, then the ratio of the velocities with which these are projected. So they are attaining the same vertical height, like the maximum height is same. What is the ratio of the velocities with which they are projected? So here we will be applying the formula of the H max. So formula of H max is u square sine square theta divided by 2g. Okay. So they are saying maximum height is same. So u1 square sine square, first angle is the 45 degree, divided by 2g is equal to u2 square sine square divided by 2g. So 2g and 2g gets cancelled out. u1 square divided by u2 square comes out to be, this is 3 divided by 4, and sine square, this is 1 by 4. So this comes out to be 3. So u1 upon u2 comes out to be root 3. So value of u1 upon u2 will be root 3. There is no such option. Okay, I have committed a mistake here. This value will be 1 by 2. This will be 3 by 2. So this third option will be the correct option. Third option will be the correct option. Okay. Third option is the correct option. Question number 5. A bullet is fired with a speed of 1000 meter per second in order to hit a target 100 meter away. If value of g is 10 meter per second square, the gun should be aimed. So basically, when you are aiming at some point, like you want to hit something on the ground, you cannot directly aim at it. Otherwise, the path of the bullet is not straight line. It is performing the projectile motion. Because of g, its direction will change. So what is happening here is, this question is a little bit difficult. So somebody is trying to hit a point here. So this point is to be hit by a bullet. So bullet will be like, the gun will be aimed like this. Okay, like this. You will aim at this point, then bullet will go like this. This will be the path of the bullet. If you aim at that point, the bullet will hit here. So this height is h, which we have to find. This h we have to find, and this distance is given as 100 meter. U is given as 1000 meter per second. We have to find that h. How can we find that h? So this is the situation actually now. I thought you will not be able to understand what is actually happening here. So this is happening. So you are aiming at this point. If there is no gravity, the bullet will go like this and hit this point. But due to gravity, the trajectory of the bullet is this, and it is hitting at that point. So here, what we will do is, r is equal to u square sine 2 theta divided by g. If we are able to find this angle theta, then h is given by h is equal to 100 tan theta. That's all. So to find the h, we have to find the angle theta. This theta we have to find at what angle the bullet is fired. So from here, put the value of r is equal to 100, multiply with g is equal to u square. This becomes 10 to the power 6 sine 2 theta. So sine 2 theta comes out to be 10 to the power minus ka 3. So if this value is very small, then theta will be small. When angle of sine is small, then you can remove the sine. So 2 theta is equal to 10 to the power minus ka 3. Theta comes out to be 1 by 2000. Theta comes out to be 1 by 2000. So theta is 1 by 2000. If theta is small, then tan theta is also equal to theta. So tan theta is also equal to theta. Value of h becomes 100 divided by 2000, which is 1 by 2, which is 100 divided by 2000. Okay, this is 100 meter. No, 100 divided by 20. So this comes out to be 5 centimeter. So height at which it has to be aimed is 5 centimeter. This will be the answer. 5 centimeter high you will have to aim. Then 5 centimeter above you have to aim. Then you will be able to hit that target, which is at 100 meter distance from the point of firing. Okay. So second option is the correct option. Question number 6. The speed at the maximum height of the projectile is this times the initial speed u. Its range on the horizontal plane will be. What will be the range of projectile on the horizontal plane? If speed at the maximum height is √3/2 times of the initial speed. So what is given to us is speed at the maximum height. What we have to find is the range on the horizontal plane. So range on the horizontal plane we have to find, and speed at the maximum height is given. So what is happening here is, so let's say this particle is projected with u speed. The angle is theta. It is going like this. At the maximum height, the speed is √3/2u. So at maximum height, the vertical component of the velocity becomes 0. It is the horizontal component of the velocity. The ux is √3/2 u, which means u cos 30. Angle of projection is 30 degree. So the angle of projection is 30 degree. So the angle of projection is 30 degree. So u cos 30 is √3u/2 and theta is 30 degree. So range, formula of range is u square sine 2 into 30 divided by g. So range comes out to be √3 u square divided by 2g. This will be the answer. √3 u square divided by 2g. So range is √3 u square divided by 2g. So A option will be the correct option. So one option will be the correct option. Yes, one will be the correct option. Are you able to understand all the 6 questions? Now you able to understand all the formulas? How do we apply all these formulas? Okay, there is one more question. And what is the question? 2 stones are projected with the same speed but making different angle with the horizontal. Okay, they are projected with the same speed but the angle is different. Their range are equal. So one angle will be alpha, another will be 90 minus alpha. If the angle of projection of one is pi/3, pi/3 is 60 degree. So this is 60 degree. The other angle will be pi/6, which is 30 degree. Its maximum height is y1. Then the maximum height of the other will be, okay. So y1 is equal to u square sine square 60 divided by 2g. Okay. They are projected with the same speed, but the theta is different, na? So first angle we know. The second maximum height will be u square sine square 30 divided by 2g. Now we divide both. We get y1 divided by y2 is equal to this divided by this is equal to u square by 2g. U square by 2g will cancel out. 3/4 divided by 1/4. This comes out to be 3. So y2 is equal to y1 divided by 3. So y2 is equal to y1 divided by 3. This will be the answer. So y2 is equal to y1 divided by 3. Yes, fourth option will be the correct option. Okay. Almost all the concepts which I taught you in the today's class are covered in these questions. That's something which I committed in the beginning of the lecture. I told you, like I'll cover the concepts and then we'll solve the numerical on that. An arrow is shot into the air. Its range is 200 meters and its time of flight is 5 seconds. If the value of g is assumed to be 10 meter per second, then the horizontal component of the velocity of the arrow is. This is way too easy question. This question is way too easy. Okay, how do we solve this question? So a range is given by this formula, horizontal component of the velocity into time of flight. This way we derived the range. In t time, the horizontal distance covered by the projectile is called the range. So range is 200 meter. Ux, which we have to find, into time of flight. Time of flight is 5 seconds. So Ux comes out to be 40 meter per second. So Ux comes out to be 40 meter per second. This will be the answer of this question. 40 meter per second will be the answer of this question. Question number 8 is done. Now we talk about the equation of the trajectory. Few questions can be asked on this part as well. So what is this equation of trajectory concept? So basically, what is the meaning of the trajectory? Trajectory is the path. This equation of this path is called the equation of trajectory. So this is y-axis and this is x-axis. Okay. So how do we define this? So trajectory means path. So what is the equation of trajectory? This means equation of path. So equation of this path means a relation between y and x. So relation between y and x is the equation of trajectory. So relation between y and x is the equation of trajectory. So x is given by u cos theta into t, y is given by u sin theta into t minus ka half gt square. So put the value of t here, u cos theta, u sin theta, t is x upon u cos theta minus ka half g, x square upon u square cos square theta. We just put the value of t at these two places. So we get y equal to u will get cancel out, x tan theta minus ka gx square divided by 2u square cos square theta. Okay. So y is given by this equation. Y is also given by this equation, x tan theta 1 minus ka x upon range. This is a very like much used formula. This formula is used a lot, the other formula. Okay. So this is called the equation of trajectory, equation of the path. These are the two formulas which are like more frequently used. So trajectory means path, equation means equation of the path. So particle is moving in the xy plane. So relation between x and y will give you the equation of trajectory. relation between x and y will give you the equation of trajectory. So there are some questions on that as well. There are two questions on equation of trajectory. So the equation of the projectile is given as y equal to root 3x minus ka gx squared divided by 2. Then the angle of the projection is, what is the angle of projection? What is the angle of projection? If the equation is given like that, y equal to root 3x minus ka gx squared divided by 2, what is the angle of projection? Obviously the angle of projection is always asked from the horizontal. So y equal to root 3x minus ka gx squared divided by 2. So you just compare these equation. It was y equal to x tan theta 1 minus ka x upon r. So this first term is given by x tan theta. So this is x tan theta is root 3x. So tan theta is equal to root 3. So theta comes out to be 60 degree. So the value of theta is 60 degree. Tan theta is root 3. Value of theta is 60 degree. And this option is the correct option. So this option is the correct option. The second option. Let's solve one more question on the equation of the trajectory. This is easy, very easy to solve. The equation of the projectile is given as this. What is the horizontal range? What is the horizontal range in this case? For this question, what will be the horizontal range? If the equation of the projectile is given as y equal to 16x minus ka x squared divided by 4, what will be the horizontal range? So what we do is y equal to 16x 1 minus ka x squared divided by 64. Sorry, 1 minus ka x divided by 64. Okay, 16x we take common, it will become like this. So tan theta is 16. Like compare with y equal to x tan theta 1 minus ka x upon r. So when you compare both, the value of r comes out to be 64. If you understand this equation, then you will be able to solve this kind of questions. Is this helpful? Like on this kind of question you find in your module? Now you will be able to solve all those questions. Whatever be the name of your coaching, whatever module you are following, after watching this session, each and every question can be solved. You won't find it difficult. So completely watch it. I have included so many questions just because I wanted all of you to understand the concept properly. I wanted to make you practice in the class only, so that at least 20 questions on a small topic is a good number actually. So now we are moving into one more type of question that are asked in the exam, which are projection from the height. Projection from the height. So let's say there is a tower of height h and you are projecting a particle from this tower. So this is a case of the horizontal projection from the height. We are projecting a particle in the horizontal direction. So how do we project the particle here? So particle is projected like this. Like this, with a speed u. So particle is projected like this. Particle will move like this and it will hit the ground. So here too, this is also motion in a plane. How do we deal with a motion in a plane? We simply take two directions. One as a positive direction and other as a what is happening? Okay. So this direction is considered as the x direction, and this direction is y direction. Now vertical downward direction is taken as a positive y direction, okay, because motion is in this direction only. This is the path of the particle. Particle strikes at this point. Here again we are defining the distances like this. Particle will strike the ground like this. This is called this is the range r, and this is the v strike, the speed with which particle will strike. This angle is the theta with which the particle will strike. So you can do the two component of the velocity. I don't know what they are doing. No earthquake. They are doing some drilling work. Okay, so this is the x and y direction, and we are just going to break the motion in these two directions. So acceleration and so if I write like along x-axis, and along the y-axis, along x-axis and along the y-axis. So ux is equal to u. Is there any acceleration in the x direction? No. So velocity in x direction will remain equal to ux, which is equal to u. In this direction, it will constantly moving with the u speed. So when it strikes with the ground, the horizontal component of the velocity will be again u. Along the y direction, is there any velocity in the y direction initially? No. Acceleration in the y direction is g, which is downward, and we have taken downward direction as the positive. That's why we are writing g. So displacement in y direction, in this direction at any time will be half gt square. Velocity in y direction will be g into t. I'm not writing minus. Why? Because I have considered downward direction as the positive direction. Okay. Displacement in the x direction in any time, which will be u into t. So displacement in any like horizontal direction will be like this. So this motion can also be seen as two rectilinear motion. What are those two rectilinear motion? You just release a particle from here. It will be doing this motion, but you release the particle with zero velocity. Motion under gravity will be there. It will reach the ground in how much time? That is the time of flight. So time of flight, capital T. So when y becomes capital H, that time is the time of flight. Put y equal to capital H here. So time of flight is root over 2h divided by g. So this is the time of flight. Here vertical component, this at the time of strike in this direction, write the third equation of motion, Vy ka square is equal to 0 square plus ka 2 into g into h. So Vy comes out to be root ke andar 2gh. So Vy comes out to be root ke andar 2gh. So tan theta at the time of strike is equal to root over 2gh divided by u, and v strike, speed with which it will strike the ground, is given by u square plus ka 2gh. So these are all the formulas of horizontal projection. This is in your case, this is in your syllabus actually. There are two other cases as well which are not in your syllabus, but still I am going to teach you. So please note down all the things. This is the formula of time of flight, Vy equal to root 2gh. Everything is given here. At any point, the horizontal component of velocity will be u, the vertical component will be equal to gt. So u and gt, these will be the velocity at any time. So what are the other cases? So the other cases are so when you project a particle like this from height, so with the speed u at an angle theta, when you project like this, particle will go and fall here. So this can be seen as two rectilinear motion like this. In this direction with velocity u cos theta, and this velocity u sin theta, and this is h. Okay, the same thing is happening here. So this motion is the combination of these two motion. So this motion is combination of these two motions. So what will happen here? It will go up and then come down. This time is called the time of flight, and because of this component, it will be moving horizontally as well. That's why the motion will be like this. So at any time, the horizontal component of velocity will be u cos theta. The vertical component will be at any time, the horizontal component will be u cos theta, vertical component will be u sin theta minus ka gt. So this is the combination of these two motion. So how do we solve this? Like if somebody asks us to find the time of flight, how do we find the time of flight? Like this is the x-axis, along the y-axis I don't know what are they doing. So ux is equal to u cos theta, ax is equal to 0, vx will be u cos theta into t, displacement in x direction, not t here. Displacement in the x direction is equal to u cos theta into t. In y direction, uy is equal to u sin theta, ay equal to minus ka g. So vy comes out to be u sin theta minus ka gt. Displacement in y direction comes out to be u sin theta into t minus ka half gt square. Okay, this way we can write all the equations. So what is the time of flight? How do we find the time of flight in this case? Matlab, I don't think more than this can be asked. Only time of flight is important. Only time of flight is important actually, na, in this part. So how do we find the time of flight? So we say when displacement in y direction becomes minus h, that time is called the time of flight. So this equation, in this equation we will put h y in place of y equal to minus h. So minus h u sin theta into t minus ka half gt square. Solve this equation and we get the time of flight. By solving this equation we get the time of flight. Okay, but this is not, I don't think this is required, but I have covered this concept because in the last time in the 2023 they gave a question on this part, which was they did not give the horizontal component of the velocity, they projected a particle, a body object from a bridge in vertical direction and they gave the time. They asked something, the height of the bridge or something like that. If somebody asks you the range here, so range will be u cos theta into time of flight. So time of flight you have to find and then you will be able to find the range also. Okay, but time of flight is difficult here. Or what they could do is like they might give you the time of flight and they might ask you the height. So this equation is important. So what are we doing till now? Like what did I teach you in this lecture? I just taught you one thing, that projectile motion is nothing but rectilinear motion in two mutually perpendicular directions. So we are dealing with two rectilinear motion at a time. One in the horizontal direction and another is in the vertical direction. So there are two rectilinear motion in the horizontal and the vertical directions. In this direction rectilinear, in this direction. So the three case of the gravity, motion under the gravity, which we studied in the projectile, which we studied in the rectilinear motion, are directly covered here. Okay, let's not go into that detail. Okay, so there are few questions and then we will solve some PYQs. We will solve PYQs as well. In the end we are going to solve the PYQs, what was the label of the PYQs, and these are the questions on the part which I have just taught you. Okay, so question number 11, an aeroplane moving horizontally with a speed of 180 km/h drops a food packet while flying at a height of 490 meter. The horizontal range of the packet is, so there is an aeroplane flying at a height of 490 meter and it drops the food packet. What will be the range of the packet that we have to find? So let me explain the situation, what is happening actually here. So there's a plane which is flying like this. What a plane. Okay, and this is at a height of 490 meter. This is flying at a 180 km/h. So we multiply with 5/18, so 50 meter per second. So it is flying with a 50 meter per second velocity. It releases a food packet, so that food packet will also be moving with 50 meter per second, but it is not moving in this direction. So food packet will fall like this. So range we have to calculate. So range will be equal to u into time of flight. So u is this velocity, in t time it falls on the ground. So u into time of flight will be the range. So time of flight is equal to root over 2h divided by g. But the value of h is 490. The value of g we will put 9.8. $50. So time of flight comes out to be 10 seconds. In those 10 seconds, the range it will cover is 50 into 10. So range comes out to be 500 meter. So the range comes out to be 500 meters. So this will be the answer of this question. 500 meter will be the answer of this question. Okay. So are you able to understand this? What is happening here? The aeroplane is dropping the food packet. The food packet will be moving with the same velocity as that of the aeroplane. Aeroplane is flying at a 490 meters. So we could find the time from there. Root over 2h by g. 10 seconds. Then range is given by horizontal component of the velocity into time of flight. And it comes out to be 500 meter. Question number 12. A plane is flying horizontally at 98 meter per second and releases an object which reaches the ground in 10 seconds. The angle made by it while hitting the ground is. So these all the questions are already covered in the concept. In this concept I have covered the. They are asking what is the angle with which the object will be hitting the ground. That is the beauty of the concepts, like my lectures. Like whenever I cover some topic now, you are able to answer any question from that part. So again there is a plane. Okay, and it is flying at a 98 meter per second. The object is dropped from here. It will also be moving with 98 meter per second. But the object reaches the ground in 10 seconds. So the velocity in this direction will be gt. So g is 9.8 into 10. It comes out to be 98 meter per second. The horizontal component will be 98 meter per second. So x component and y component both are same. So the angle with the ground will be 45 degree. Tan theta will be equal to 1. Angle will be 45 degree. So at 45 degree, the particle will strike the ground. At 45 degree, it will strike the ground. So the answer comes out to be this. Okay, so at 45 degree, it will strike the ground. 13th, a particle is dropped from the height of 20 meter on a horizontal ground. There is wind blowing, due to which horizontal acceleration of the particle becomes 6 meter per second square. Find the horizontal displacement of the particle till it reaches the ground. So this question is a little bit different from the questions we have covered till now. What is happening here is like a particle is dropped and this height is given as 20 meter. So if nothing happens, so due to acceleration, due to gravity, this particle will reach in the ground in what time? So time taken is, what time it will take? Root over 2h divided by g. So this comes out to be root over 2 into h is 20 meter divided by g, 10. It will take 2 seconds in reaching the ground. Okay, in 2 seconds it will reach the ground from 20 meter to ground. But what is happening here? There is a wind and which is providing 6 meter per second square horizontal acceleration. So now you say, sir, will the time be affected by this 6 meter per second square? I'll say no. Why? Because this motion and this motion, they both are independent from each other. Now because of this acceleration, what will be the path of the particle? So there is net acceleration will come out in this direction. Is there any velocity, initial velocity? No. So the path of the particle will be rectilinear. Okay, path will be rectilinear. This is very important. Rectilinear. It will go like this. It will not be projectile. It will be rectilinear because initial velocity is 0 and net acceleration along that line, the particle will move on that line only. When there is constant acceleration and velocity, they both are not in the same line. The path is parabolic. But here there is no velocity, so the particle will move along the net acceleration. So it will be rectilinear. Okay. So in 2 seconds, what will be the horizontal displacement? X is equal to half a in x direction into t chi square. So half 6 into 2 chi square, which comes out to be 12 meter. It will travel 12 meter. This distance will be 12 meter. So it will travel 12 meter in the horizontal direction. It will travel 12 meter in the horizontal direction. Is this clear? Question number 13. Question number 14. A missile is fired for maximum range with an initial velocity of 20 meter per second. I think this was your PYQ. The range of this was very easy PYQ, no? Like, what will be the maximum range? So what is the formula of the maximum range? U squared divided by G when theta is equal to 45 degree. Okay, so maximum range comes out to be R max is equal to U square. U is 20 chi square divided by 10, which comes out to be 40 meter. So the range of the missile will be 40 meter, and that was your PYQ. I think in 2019 or before that it was asked. Oh, no, 2011 or something. So this was the question. This is your PYQ actually, and this level of questions we have already. This level of question we have already covered. Sir, how it will be rectilinear? Yes, yes, that was a good question, and I was waiting for someone to ask it. Okay, I was actually waiting for somebody to ask it, like, why are you calling that motion as a rectilinear motion? Okay, so how do you define, like, how do you find able to differentiate the type of motion? So there are few types of motion I'm going to tell you. So if initial velocity is 0 and acceleration is constant, then particle will attain velocity in this direction only and it will move rectilinearly. Okay, if acceleration and velocity are in the same line, then also rectilinear. So for a motion to be rectilinear, these are the few conditions. Okay, either the initial velocity is 0, acceleration is constant. For a motion to be projectile, acceleration and velocity acceleration must be constant, and there must be angle between them. So in the previous case, what is happening? A particle is released. So u was equal to 0. There was one acceleration g, one acceleration a. Okay, so the resultant will be like this. Net acceleration was like in this direction. Is there any velocity given to this? No. So what will be the, like, if velocity comes, then what will be the direction of the velocity? This. So particle will move in this direction only. Got it? Why the motion in the previous case will be rectilinear, not projectile? Because this is not velocity. If this would have been the velocity, then it will be projectile, parabolic path. But net velocity, initial velocity is 0 and particle is given net acceleration. So it will be moving along that line and it will be rectilinear motion. Next, PYQ. A projectile is fired at an angle of 45 degree with the horizontal. Elevation angle of the projectile at its highest point as seen from the point of projection. what they are saying is a particle is fired from the ground. A particle is fired from the ground. So they are asking, this is the line of sight, no? This is the line of sight. What is the angle of elevation? What is the angle of elevation? This is h max. This is r by 2. Okay, that is the h max and this is the r by 2. So they are asking this tan theta. So tan theta is given by h max divided by r by 2. Okay, when the particle is at maximum height, now when the particle is at here, you are looking the particle from this point. So this is the line of sight, angle made by the line of sight they are asking. So tan theta, actually call it alpha, otherwise you will get confused in theta and alpha. So tan alpha comes out to be u square sin square theta divided by 2g divided by u square sin 2 theta. I can write that sin 2 theta as 2 sin theta cos theta divided by g. So g से g cancel out, sin theta से sin theta cancel out, u square से u square cancel out, and it comes out to be tan theta divided by 4. So tan alpha is equal to tan theta divided by 4. So theta is 45 degree. So tan alpha is equal to 1 by 4. Oh, none of the option is given like that. Did I do something wrong? Yes, that was r by 2. So 2 से 2 will get cancel out. So this comes out to be like this. So alpha is equal to tan inverse 1 by 2 will be the answer. So alpha is equal to tan inverse 1 by 2. Alpha is equal to tan inverse 1 by 2 will be the answer of this question. Now let us talk about motion in 2 dimension. Actually, few people teach it before the projectile motion, but we can also cover this after the projectile motion. It is a little bit boring actually, na? That's why I kept it for the end, and we'll finish it in the next 5 to 10 minutes only. So this is x-axis, this is the y-axis. A particle start moving from this point to this point and goes to this point, okay? This is the initial position vector, final position vector. So when particle is moving, both the x and y coordinate are changing. So its position vector is given like this: x, which is a function of time I cap, y, which is a function of time j cap. So the position vector of the particle is given like this. When you want to find the velocity of this particle, you just differentiate r vector, dr vector divided by dt. So dx over dt I cap, dy over dt j cap. So velocity comes out to be, velocity vector comes out to be vx I cap, vy j cap. So vx is equal to dx divided by dt. X component, you differentiate x component, you get vx. You differentiate y component of the position vector, the y coordinate of the position vector, you get the velocity vy. Acceleration comes out to be differentiation of this dvx divided by dt I cap, dvy divided by dt j cap. So you don't have to take both the directions simultaneously. You can take one direction and you can proceed in one direction only, like x direction you take, initial velocity you take, acceleration you take, and then find the displacement and everything. Y direction can be independently taken. So when particle is at this point, let's say it is moving like this. So x, this angle is theta, this angle, so this will be y component, this will be x component. So x component is equal to v cos theta, y component is equal to v sin theta. They both are x and y components. So there is a question on this part as well. A particle has an initial velocity 2i cap plus 3j cap and the acceleration of this and this. Magnitude of the velocity after 10 seconds will be. Anyways, this is a easy question actually, na? So in 2 dimension also we can apply, because the acceleration is constant, so we can apply v vector is equal to u vector plus ka a vector into t. This equation we can directly apply in this case. So v vector comes out to be 2i cap plus ka 3j cap plus ka a vector is 0.3 I cap, 0.2 j cap into 10 t. So v vector comes out to be 5 I cap plus 5 j cap. The magnitude of velocity at t equal to 10 seconds is 5 root 2 meter per second. 5 root 2 meter per second will be the answer of this question. 5 root 2 units will be the answer of this question. Okay, one more PYQ. The horizontal range and the maximum height of a projectile are equal. The angle of projection of the projectile is. So if horizontal range and the maximum height both are equal, what will be the? If the horizontal range and the maximum height are equal, then what is the angle of the projectile? So they are saying h max is equal to r u square sin square theta divided by 2g is equal to u square sin theta cos theta divided by g. This gets cancelled out, u square cancel out, sin theta upon cos theta is equal to 4, tan theta equal to 4 will be the answer. This was your PYQ. Theta equal to tan inverse 4 will be the answer. Okay. Theta equal to tan inverse 4 will be the answer. This was easy question. Done. 17. 18th question. That was also PYQ. A projectile is fired from the surface of the earth with a velocity of 5 meters per second, okay, and at an angle of theta with the horizontal. Another projectile is fired from another planet with the velocity of 3 meters per second at the same angle, follows the trajectory which is identical to the trajectory of the projectile fired from the earth. The value of the acceleration due to gravity on the planet is. So what we can do is we can equate the maximum height and the range. The value of the acceleration due to the gravity on that planet will be. Okay, this was a really good question. So a projectile is fired from the surface of the earth. Okay, so the trajectory is same. That means ki what you can do is maximum height and range we can do the same. So maximum height is 5 range is 5 square sine 2 theta divided by g is equal to 3 square sine 2 at the same angle. At the same angle is also same. So sine 2 theta divided by g dash. So g dash comes out to be, this was very easy question, g into 9 divided by 25. So 18 divided by 5, g dash is equal to, very easy. Okay, 3.5 will be the answer. Put the value of g equal to 9.8, then you get the, yes, value of g we have to put 9.8, then you will get the 3.5 meter per second square. So the trajectory is same. So I just equate the range in both the cases, and we got the, directly we got the g. Because theta is same, speed are different, the acceleration due to gravity will be different, then only the trajectory can be same in both the cases. 19th question. The x and y coordinate of the particle at any time t are given by this and this. The acceleration of the particle at t equal to 2 seconds is. So there is like x coordinate is given as 10t. So velocity in x direction will be equal to 10. Y coordinate is given as 5t minus ka 2t square. So velocity in y direction will be given as 5 minus ka 4t. Acceleration in y direction will be given as minus ka 4 meter per second square. The net acceleration is only in y direction because acceleration is not in the x direction. So net acceleration will be the y component of the acceleration will be the net acceleration. The second option is the correct option. This level of question were asked in the NEET. These are the NEET PYQs. I think this is the NEET 2022 PYQ. A ball is projected with a velocity of 10 meter per second at an angle of 60 degree with the vertical direction. The speed of the highest point of its trajectory will be, highest point, at highest point the velocity is only x component, which is u cos theta. So the angle is given with the vertical. Most of you will be able to solve this wrong. So that will be sine cos 30 we will have to put, because the angle with the horizontal will be 30 degree only. Now the 5√3 will be the answer. (5√3) will be the answer. Most of you might stuck here. Okay, might solve it wrong because of this. The angle is given with the vertical, not with the horizontal. Oh wow, we have solved 20 questions on projectile motion in a lecture. All the concept, all the formulas and 20 questions we have covered in the less than 2.5 hours, less than 2.5 hours, almost 2.5 hours we are done. Like this chapter is very like this not that big chapter. So rectilinear took 4 hours, this took only 2.5 hours. You got free early. I did not thought that. So basically there's a NEET Endgame 2.0, the ultimate crash course starting on the 22nd of January. The price of this course are 4499 rupees. Any one of you wants to enroll for this course, there is a referral code Kailash 10. Use this referral code and enroll for this crash course. Amazing crash course where all your favorite educator are teaching you, and this crash course is dedicated, like 100 days crash course is this. Like total number of days in which this crash course is to be completed is 100 days, and this is dedicated crash course for NEET 2024. So any one of you wants to enroll for this crash course at the price of 4499 rupees, the referral code is given above, Kailash 10. Use this code and you can enroll for this crash course. There is one more Unacademy scholarship test for IIT JEE and NEET at the rate of 99 rupees, and you don't want to miss this Unacademy scholarship test. So there are rewards as well, MacBook, iWatch and other learner awards, special learner award, laptop and gadgets. So this is happening on every day 11 a.m. to every day 11 a.m. to 7 p.m. Okay. So Kailash 10 is again the referral code for this also. So guys, today we got free a little bit early because topic is complete. This was a small, like not that lengthy topic actually, na? So the next topic will be relative motion, Newton's laws of motion and so on. And till then, it's time to say bye-bye. Class is very interesting. please do not forget to comment after the class. Once the class is over, please do comment whatever was your experience. I have, like, this chapter was a little bit easy and small, so I could complete this in less than 2.5 hours. But I hope the illustrations of the class will definitely help you. Whatever material you are following, whatever coaching material you are following, you will be able to solve that material after watching this class. You won't find it difficult. Like the each type of question I have covered, almost all the type of questions are covered in this lecture only. And don't forget to like the session. You have already liked it, but you have to like it also. Okay, thank you. Bye, take care.